Hello everybody, welcome back to this week's video. Following what we taught in class, today's, well, honestly, probably pretty large video is going to consist on multiple other tools and things that we can use Wwise for. Some very necessary, some not as much so, and others just like very reliant on the things that already exist. We're going to be working a lot in engine this week, and therefore our two engines of choice are going to be slightly different as the approach that we have for this. That being said, the logic is relatively similar. If you were checking Michael's examples for things, I did a small tweak to one of the exercises to make it a little bit more apparent. But that's pretty much it. So today we're going to be covering first, we are going to be looking at how to utilize less events into our configuration so that we can save a lot in processing power. We're also going to be checking how to synchronize with states. As we have talked before, states are really important in game development spaces, and therefore we want to get the most use out of those, synchronizing them and being able to utilize them in our Wwise operation is really useful. And then we're going to be utilizing game parameters and trying to grab those values from our engine and put them into use in our configuration in Wwise. Finally, we're also going to be showing blend containers and how to measure between two audios and see a transition in between them. That's pretty much it. So first of all, let's jump into the engine and check where we were last week. So in Unreal, we were we worked a little bit on our spaces. We had worked on our footsteps, and then we transitioned our spaces into this nifty snow patch thingy that allows us to jump back and forth. Yeah, we have that. We also have our sound cube over here that gives us like this eerie vibe, especially we're standing in front. So that's where we're at for now. Now, the first thing that we're going to be working in is how to configure objects for multi-position configuration. This is a relatively simple adjustment in Unity, but it's a little bit more complicated in Unreal. The reason why we do this is to utilize a single AK ambient or a single autokinetic object instead of having multiple of them playing at the same time, which would require a lot more processing power while keeping the same auditory experience. So we are going to do that by approaching the scene from a couple of perspectives. The first one is we're just going to create a small section here of 4 cubes. We're going to listen to them through the original configuration that we have for our sound as it exists right now, because we're going to use the same eerie cube sound that we have had before. So for that, I'll create a folder called multi-position cubers, and I'm going to create a couple of cubes that are going to go in there. So I have my cube, I'm going to put it in the folder. Then I'm going to do a small configuration because we have already done our audio player as an object that we can add. So I'm going to add that audio player to my cube. Then from there, I'm going to grab the audio player and I'm going to change the reference. I'm going to say that this is playing Digital Horror Pulsating Breath, and that the actor is the cube, which is itself. I don't know if that is the only cube that I have, so I'm just gonna drag and drop it there. Just to test if it is working correctly, let me walk to it. Okay, and there we can hear it. Perfect. I may raise the volume of that sound a little bit in Wwise in a bit. Okay, cool. So we have a sound and it is playing the sound that we need. So now I'm going to duplicate that cube a couple of times. And then let's make a bit of a street. Something like that. Say the cube 2 is over here. So let's make it a little bit better measured. So like here, let's say, and then if you go off by 3, so let's say that it goes, yeah, that's fine. And you, I can select to be 1, 2, over here, and then over here. Perfect. It's not the greatest, but the reason why we're doing this example is so that you can hear the multi-directionalness of it. All of them right now, because they are duplicates of each other, should have the same configuration, so I'm just going to walk to them. So you see in here that the sound is concentrated while I'm in the middle, but the sound is concentrated and the directionality exists, but you can hear all of them at the same time. Now, the way that we can use to make this a little bit more apparent is, of course, utilizing our profiler. So I'm gonna go to the profiler, check a connection, play it here, and I'm gonna make the Unreal window a little bit smaller with code to see if we can play it. Okay, so you see now, let me just walk to the thing. Alright, so we see all of the events that are appearing on top. Let's take a look here at what's happening. Let's disconnect for now. Let's look at what we had here. So first of all, from the beginning, we had a switch that was switched to dirt as the default value, but then here we got 1 event, 2 events, 3 events, 4 events that were playing all at the same time. All of those were the exact same sound duplicated into 4 of them. When we got slightly closer, there the profiler was telling us which event was playing, but all of them started playing on start, and we have a bunch of the other footstep sounds that were going to be appearing on the section, but these 4 sounds continued to play throughout the whole state. That created a bit of a loaded time. We also have these selection in the timeline in which we hear, let's look at the voicings, all 4 objects being configured by different objects, because you can see here there's cube, cube 2, cube 3, and cube 4, but it is the same type. So we don't need to do this. We could make the game objects change, but like have the same value for the same, not value, the same sound being played for multiple directions without the need of creating multiple event, like post-event situations. So 2 solutions to that object: position mode and large mode. Large mode is going to be, we're going to talk about it in a little bit, but multi-position mode allows you to have that space in which the same sound is going to be played by multiple, multiple positions, multiple objects, without requiring the extra power. Right. So one last change that I want to do for these objects is that I know that the attenuation sphere is quite large. So to make these a little bit more apparent, I'm gonna spread them a little bit, just a couple of squares more into each side. And I'm also gonna change the attenuation on our cube a little bit, just to make it more apparent, honestly, not any other reason. So right now we have like 1,000, let's say 500. Let's see if that's enough. Also, when you have your setup connected, your sounds will appear here. It will tell you what component contains the sound that you're playing. So let's listen to that, see if it's up. Almost forgot. Soundbag generated. Let's see if that works a little bit better. I haven't changed the configuration, just to see if the sounds feel. Yeah. I also will turn off the cone attenuation because I think that I need the extra noisiness. We're gonna get to you. So we go back. Designer layout, let me select that, and then I will turn off the cone use. Perfect. Okay, this should be good. Actually, it may be a little too small. Let's keep it at 600 because now I don't have the continuation. Okay, so once again, let's try and camera location. That's how it sounds, right? If I step from the middle, I will listen to them like very softly. That's part of the idea. So how can we change it? So for these, we are going to need to have a central object that we are editing a little bit. So the first thing that we need to do will be to create a new object that we can contain all of our materials in. So I'm going to create a new blueprint class, and that's going to be an actual blueprint because I want to be able to put it into it. Again, this is supposed to be a modular system that you can use for multiple things, so I'm going to call it a multi position player. So we have an audio player and a multi-position player. The difference being that the multi-position player will require more options for them. That being said, that also means that I'm going to delete all of the audio players from the cubes that I originally drafted. I'm going to add the multi-position player to my scene. Now, I'm going to add this to the folder, and we're going to talk about what this is going to do. The objective is basic. I'm going to change the configuration of this blueprint. Actually, let's edit in a blueprint so that we have that here. And I'm going to, on event begin play, post an event. The logic is still going to be the same that we had touched on before. Post the event when I need to. The difference is that we're not going to post the event on location. So you see that in the post event, it asks me what the actor that is going to be playing is. We're going to change that configuration. So for that, I am going to utilize a different post event that is going to be post associated event. So post associated AK event. This is targeting an AK game object, and that AK game object is going to be containing all of the information for that value. So whatever this position is being made or whatever it is being placed, this is the place where it is going to have. So I don't need to, I am already selecting what the AK event and what the actor are, and all of the other ones are the same. So it is a little bit of a different configuration, but I'm basically extruding both of the information here to the same object. So later, in a little bit, we're going to be grabbing a new AK reference. And when we do that, we're going to need a variable to contain it. So let's say that this is going to be an AK ambient reference. Once again, I'm going to go ahead and change this value from a Boolean to an AK ambient sound object reference. And we're going to drag it and put it into the value. Now, let me make this available here. One thing that it is important to note is that I don't make this selection by itself. When I do it, I am grabbing the AK component from the AK ambient object outside, and it is that AK component that I'm going to be editing around. So once again, we are populating the AK ambient reference, but in this moment, this is just the same thing that we did on the post event that we have done until this point. The difference here is going to rely on the position, right? So for both these and the configuration later that we're going to do for lash mode, I'm going to use a different object. That object is going to be called a different node. Sorry, set multiple. Let me turn this on back again. Set multiple positions. So this is what the configuration is going to be like, or the basic configuration. I'm going to change the configuration of the AK game object to change the positions in which it is going to be played. Instead of having just the target position, I'm going to set multiple positions that are all going to be assigned to the AK game object. And then after those positions are being set, when we post the associated AK event, it is going to not play on the single position that the AK ambient is on, but in the multiple positions that they are. From that, I'm going to change this to single source because I don't think that I need to make a higher configuration for that, like multiple sources to them. We may change that in a little bit. So now the next thing is just going to be how do I populate those positions? So in our case, because we're grabbing the positions from a lot of objects that already exist on screen, the cubes that we have added, we are going to just create an array that allows us to select all of these meshes, add them into a list, and then that list extrude their transforms and feed them into our positions, a set multiple positions node. So for that, first of all, I need to create a new variable. That variable is going to be cubes. And it is going to be not an AK ambient, but a mesh. A mesh actor. Go up. And is it not a mesh actor? You can see a static mesh actor, that's my bad. You can see what type of object it is here on the type part of your outliner. So they are static mesh actors, that's my bad. Let's go back to the selection, look for a static mesh actor. There we go, object reference. We're gonna make that public because we're gonna feed them the positions of all of our cubes from outside, but I'm also gonna right click here to turn it into a matrix. You could do it right clicking here, or you could also do the selection here on the top right. So the idea here is that we're gonna feed those cubes into these transforms, but once again, this isn't making an immediate transition. I need to create a new matrix that feeds those positions or that appends those positions into a list. So I'm going to go ahead and create a new variable, and that new variable is going to be like the cube transforms. It is still going to be a mesh, but instead of just be a matrix, but instead of being a mesh, a static mesh actor matrix, it's going to be a transform matrix. So that's the idea. Grab the transforms from here, put them into the cube transform, and then feed those transforms into the position. Okay. For that, to populate this, I'm going to be utilizing a simple for loop. So let's go for loop, and we're going to use a for each loop. That's fine. Let's add the cubes to the array, and then I am going to grab the loop body and utilize that loop body to feed onto our cube transform. So I'm going to go here and then add, so that I can add every time, and I'm going to add an array element, but of course this is not going to work. So I'm going to get actor transform, and that transform we're going to value here. So every iteration, every time that we go through one of these subjects, one new transform is going to be added to the cube transform array. And then after we're done, we're gonna grab those positions, set the multiple positions, and then play the event. I'm going to compile this. Let's go and populate our variables. So now here, the next thing that we need to do is, of course, we need to create new actors. I'm going to go back to my Windows selection to get the Get Actors window. And in here, we're going to look for AK Ambient Sound. I'm going to grab that new AK Ambient, and I'm going to put it into the multi-positional cubes. Let me put it a little higher. Actually, let's just, where is this like in the center? If I zero this out, does it go far away? Yeah, yes it does. Cool. So what is the sound that we're going to be playing? We're going to be playing the same play digital pulsating horror thing. I need to change that sound. And in theory, when I play this, it should center around each of these objects, even though it is on the other side. Now, here in my multi-positional mode, I have, first of all, the AK ambient reference. I'm going to lock these panels so that I don't have to go back and forth. I'm going to select my AK ambient sound that I'm going to use for this, add it into my reference, and then I need the cubes. So I'm going to add 1, 2, 3, 4 variables. Those are going to be cube 1, cube 2, cube 3, and then cube 4. Perfect. I'm going to go back to my script because I don't know if I compiled it. Compile it, save it, make sure that everything is saved. And now, if everything works as intended, I should be able to hear the multi-positional configuration by walking around. I'm going to change the play to play in the current camera location. That way I don't need to walk every single time. Let's play. Hit it there, we hit it there, we hit it there, we hit it there. But I think that the sound that we're hearing is not that. Okay, let's do a quick test. I'm gonna put these outside. Let's play it. Yeah, it is only the sound is only playing from the AK ambient sound. So let's see what's happening. Now, of course, the change is that I had it in the multi-position type as single source, but it is multi-source. That's the whole point. It's multi-position. Yeah, there we go. So you hear that it is coming from each of the directions, but the true test is going to be through the profiler. So let's really quickly go to Wwise, to the profiler layout. Let's clear this space, make the connection again. I don't need to do that. I can just click the reconnect button. Everything should set up. I'm gonna make my Unreal window smaller. And then when I play, let's do this. Stand over here. Okay, let's take a look. Let's disconnect that. Okay. So, first things first, at the very beginning, we have an event triggered play, but it's just the one event that it is playing. If we go into the, do it through the listeners? No, send sidechain the audio devices, emitters. Oh, well, there's the memory loads. Voice graph is pretty good. Okay, so we got the event being triggered in a different space of time. If I go deeper in, let's see, there we go. I'm looking for the moment when we first start hearing the sound. So in here, there we go. You can see the audio for the first person being played. I'm trying to find. I think the voices will probably be better. If we look at the game object for each of them, not that extension, but this one, you can see how the component is the AK ambient sound. That is the one that is being played, and it is the only object that is maintaining playtime over the course of this whole time. So like the event is playing in all of these different sources, but it's just one AK ambient object that is, well, which is our ambient sound object, the thing that it is playing, and it's just the change of configuration into multi-position, the thing that is allowing us. In the space of play of the actual event, the action being triggered, like on event, the thing starts to play, and then that's it. There is no other extra event that is happening until the end when we stop and we finish it. What does that mean? That like for all of the configuration that we had done before of having like multiple elements, this utilizes a lot less energy, but it maintains all of the different configuration purposes that we had for our game. So that's really, really useful. The next thing that we're going to be covering is large mode. Large mode is a different way of doing the same thing. It has a different purpose. Instead of having like multiple sources that we are trying to listen for, we are just having one source that we don't want to have like a very particular point for it to be the source. This is really good when you have like something that the sound feels more ethereal. So let's say that if you've ever been like in a school, like a very big school a cafeteria or something like that, in which like the voice of everybody feels like it's making the noise all around because it's very reflective on the surface. Or let's say that you were in a place in which the whole, well, any room in which the whole room feel like making the noise, and it's really hard to pinpoint where that noise is coming from. Or also, if you were doing something like having music or sound effects or things being placed like around multiple positions, and you want them to be like surrounding the player instead of being like a very particular position. Large mode is really good for that. It allows you to create multiple points in the space that all play the same sound, making a very circular, omnidirectional soundscape for that particular audio source. For that, we're going to be utilizing our snowfield that we made in the previous week, and the configuration of that snowfield is what's going to allow us to play the game. So the first thing that we're going to do is we're going to grab our Wwise scene and add a different value to that. Add a different value to our a different value, no, a different audio to our library of sounds that we're going to be working with. For this, we are going to be going into our library. So let's say audio library and the GDC, and then inside GDC, I'm going to look for a new blue zone sound. Sorry, that's together. And I'm going to be using the blue phone heaven. There we go. We're going to use these two sounds throughout these exercises, so I'm going to grab both of them and add them into the default work unit. I'm going to leave them as is, and then I'm going to create a folder that is going to contain them. So this is going to be the virtual folder. I'm going to call them, let's say, Snowfield. So that, Snowfield. And I'm going to be changing in between both of them depending on the configuration of our audio. So the first one, both of them are going to be playing throughout the whole time that I'm going to be in the game. So I need to make them loopable. I'm going to loop this. That's a little loud. Let's put them at like -4. Very dark. One is also very loud. Let's see the like -6 in this one. That's pretty good. Let's put this at -3 actually. So both of them are more or less the same volume. Yeah. Okay. Now let's check if they're loopable. So I'm gonna do the selection. Let's put you at the very end. Didn't put loop in this one just yet. Okay, so I think that I can create like a bit of an out-in situation just because it already has it, but I need to make it like way, way smaller. And then cut it like over here probably. Let's check. Yeah, it needs to be smaller there. Let me make these bigger so that I can check the actual size. Quite like that. Let's make it even smaller. Let me go back up. It's not ideal, but it's what it is. This one does have like a good cutoff at the end as well. Let's try it out. I think that for this one is fine because that starts from the beginning. So let's do that. Let's make like a nice transition. Okay. Anything else that I need to do over here? No. So the idea here is we're later going to be creating a sound that when you approach the snowfield changes from one thing to the other, and that the sound that you have when you're inside and the sound that you have when you're outside is going to be a little bit different. We're going to be create this, to render the changes into the first sound, and it is that sound that we're going to use at the beginning, and then the other one we're going to use when we are touching on states. Okay, so this is done. Let's go to the soundbag, generate checked. It's perfect. Okay, so now in here, one more thing that I think that it's worth adding is that we did the configuration for these four with the multi-position mode. But if you were to, let's say, not have the configuration of this player as such, like that it grabs the cube, but we did like get all actors of class. And then this was like an extra, an alternative variable. So if begin play was not like this, but we did like connect this, and then let's get the cube's position out. something like that. And then here we put a variable that was, what are you checking? Actor class reference. So actor class well, any of these things. Like you could select actor or get river volumes or get whatever else you need, like the type of actor as a variable and attach it here. And then this out actor gets attached to the type of array that is being created here. You could select all of the cubes, for example. Oh, this is all actors of class, but if I did like get all actors class with tag, and the tag was, let's say, actors that says cube or something like that. You could get all of the torches or all of the cubes or all of the something extra that you have programmed, and that way, instead of these being the positions that we are selecting and us having to manually select what positions are part of the multi-position mode, you could, in theory, create a system that makes every torch play in multi-positions, and that would be really useful for you if you have like an attempted sound. Now, speaking of the large mode, if in this configuration, we need, again, to create the space for a large area. This is really useful for things like rain, for example, that comes like the sound is like omnipresent. As I mentioned before, something like a restaurant or something like that. But in our case, we are going to create just this vibe for this specific snow field. However, because it is going to be centralized in the snow field, I need to have control of the snow field as a whole to be able to manage that. That means that we need to do one of the methods that we haven't used so far, which is transform this snow patch into a blueprint object. So I'm going to click here and create a new subclass static mesh actor. That is going to create a snow patch blueprint. I'm going to play around in here, but first, before I do that, let me just put this in the Wwise tutorial objects folder. I'm going to go back and position all of my other things that were inside the snow patch there. Functionality doesn't change. I just have this button here to be able to edit the patch. Ah, yeah, of course, I also have that for the cube speaker. I forgot that we have it as an object. Okay, great. So now the next thing that we're going to do is I'm going to edit this controller. Let me close the other spaces, and now we have the snow patch here. Here's my event graph that I can use, and here's the viewport. In this viewport, we're going to add the points that are eventually going to be part of that large mode. For that, we are going to use an object called spline. Spline creates a line of multiple points that create like sharp movements. And it is each of those movements or each of those points that are going to be the audio source from which the audio emitter from which the audio source is going to play. So we're going to generate a couple of points. Let's click you have here the space in which the points can be controlled. You can select the first point or the second point and go back and forth. You can also add a previous point and add one a little bit later. And we are going to be moving through those. So right now we have 2 points. We are going to need 5. So I'm going to add, let's start here at the center. The center point is going to be 0, 0. That's perfect. Then the next point, you see here that the location is 100, 50, and 50. I'm going to make them each of the corners and the center. So I'm going to change these to 50. That's going to put me in the edge. Then I'm going to use 50 here to start there. Now I'm going to add the next point. That next point is going to be 0 on this initial position. And then, that's 50 here, and then minus 50 here. Now let me check that I am selecting the same amount of points. No, I'm not. So in the 0 one, I'm gonna go back to 0 and 0. And then the next one is gonna be 50 and, sorry, this minus 50. Yeah, so we have 0.0 and 0.1. We're gonna add a new point, which is going to be here. Add next point to start current selection. That. And let's see, we still have 0.1 and 0.0. Those are both of them. Sorry, so after I have this one set up, I'm gonna right click here and add a new spline point. I'm gonna do that a couple of more times. So we need 5 points in total. Let's add this one here. All right, so 0.0 is going to be 0, 0, 0, and then 0.4 is going to be the last one. So 0.1 is going to be 50 and 50. The next point we're going to be minus 50 and 50. Then the next point is going to be minus 50, minus 50. And then the last point is going to be the one that it is 50 and minus 50. So we have all of these 5 points that are there. I'm gonna go ahead and select all of the points and raise them up a bit. Make sure that they are in to like 5 as the height, just to make sure that they are raised over the actual object. And now you'll see that this is kind of like a circular space. We can change here to linear, that way the points are closed off and we have our separations. Now, when you're doing a large mode, it is important for the points to be separated in relation to the attenuation area that you're trying to cover. If they are overlapping, you're probably doing correctly your job. But if the pipe that you're trying to create is so that each like it feels like a complete source, you cannot have multiple points in which the attenuation is very noticeable. So playing around with the attenuation or how close you have the points is really important. If you have this configuration and the attenuation doesn't feel appropriate, maybe make the attenuation bigger or create more points to cover for that distance. Cool. So now that we have the points, we can go to the event graph and play around with it a little bit to populate them. So the approach that we're going to have is going to be really similar. We're just, instead of having the other points, we're going to use the points from the spline to be able to locate the correct functionality instead of utilizing the points from a previous thing. That being said, the final step is going to be the same, which is set multiple position and get associated, not get, post associated AK event. That also means that we do need an AK ambient object reference. For that, we're going to play here and add a new AK ambient AK game object. That AK game object, let's call it snowfield, and it's the thing that we're going to be using. Now, that being said, the position is still going to be the same. We're going to target this here as our target, and so this should, of course it doesn't, because this is made a small mistake here, because what I'm looking for is an AK component, not an object. Cool, so you are going to be snowfield. I'm just going to change the name of the variable. You are going to be the component that I'm going to be using. So snowfield, excellent, gets in here. Now the configuration of snowfield we're going to do in a little bit, but this is going to be our endpoint. It's going to change the multiple positions, create this from multiple directions or multiple sources. Multiple directions is actually better than multiple sources in this case. And we are going to use spline to populate the positions for that space. So for this, I'm going to grab spline and I'm going to, you know what, let's do it a little bit different than what we did before. Instead of doing a for each loop, even though that would work the same, I'm going to get the number of spline points. And in those spline points, I'm going to create a for loop that is going to count not for the first index, but for the last index. So starting from 0, I'm going to count to the maximum value of the spline points that we have. And we're going to do one thing each time. Now, the next thing is, of course, in an index, I'm going to get a location of spline. Get location at spline point. So if in each position, I'm going to target that position. And the target is, of course, going to be our spline. Fantastic. And now the return value, it's a vector. We are trying to make it into a transform, which is going to equalize where that position is. And then that return value is finally going to be added into our new matrix. So let's click add here. That's not the type of add. So first things first, I guess, let's make a transform. So let's say spline transforms. Make this a transform, make this a matrix, and then this is what I'm getting. So in here, I'm going to add this value. Perfect. Let's make a connection here. And then the rest is the same. Once that is completed, I will set multiple positions and post the event. Perfect. Let's see. Is there anything else that I'm missing here? I think that I can, let's organize this a little bit. It's too far away and it's hard to understand what is happening. So let's put this over here. Let's grab these two things, put them like high up. Then here we have the for loop. This is here. So let's lower this. That way every line is visible. Cool. So it's a simple procedure. It's the same idea. We are populating the transforms through the positions of splines that we are getting through the make transform and get location at spline point object. All of these objects are private, and we have right. And then after doing all of that, we get those spline points and we utilize those positions to play the game, play the sound. Now, of course, I still need to populate these. So in my objects, I need to select my snowfield audio event. And I'm going to go ahead and play my audio event. That being said, I can't do that because I haven't created those just yet. So I'm going to go to snowfield, reconcile these assets. Then when I play this, I should be able to hear my sound. So let's go back to snowfield. No, sorry, I was already in editor. IK audio event, play snowfield. And we should be able to hear it. Oh, big important step that I forgot is that snowfield does not have an attenuation. So I'm gonna go back to here and add a new attenuation to it. So let's go to all. And in here, I'm wondering if I should make a new one. Nah, let's leave it at that. Let's create a new attenuation. This is going to be called the snowfield attenuation. And it's going to be pretty straightforward. As we know, in Unreal, distances are a little large, so I'm going to leave this at, let's say, 2000. And then let's apply a locus filter. Custom event. I'll just leave it like that. Let's lower this a little bit so that we can still hear some of those. And then I'm going to adjust the volume because I think that it is a little loud on the engine. So let's do it like -12. It's maybe a little low, -10. Yeah, let's keep it there. So I'm going to save, go to layout, soundbank layout, generally checked. I think here is good. Let's go here. And then the closer that we get, we should be able to hear it. Why can't we hear it? Important mistake. I forgot to change the positioning. So the location in which these are made are all measured in local spaces, which means that they are checking for the address of those spline points, or at least the transform position of those spline points in reference to the rest of the space. That means that I need to change my configuration from local coordinates to world coordinates. That way, instead of grabbing the transform position in reference to just in general, which was what we did, like 0, 0, 50, 50, minus 50, minus 50, etc., it was grabbing, it will grab that in reference to the position of the actual snowfield. So now that we have done that, I also activated the position so that it was easier to hear. Like if I approach this direction, you see that we have it, but if I'm inside, it comes from everywhere, right? All right, so that is large mode. The next thing that we're going to be working in is game states. As we mentioned in class, and we have talked about multiple times, game states are really important for development, and we are just going to try to get used to, or like use other game states that already exist into our configuration to make it to make sounds a lot more dynamic when we are utilizing them. In our case, we're going to utilize that snowfield, that snow patch that we have been working in throughout the last couple of weeks. And the idea here is that we're going to change the idea of like the state will be, is the character on the snowfield or not? If it is, we're going to transition the music from one thing into another. As we mentioned before, this is different to switches in the sense that switches, you have to assign each of them like together. With states, you can tell objects how they need to behave. So first, we're going to go into Wwise, look at how objects are going to change, and then we're going to apply that into our engine. So when we move into Wwise, the first thing that we're going to do is we're going to change the events a little bit. Because we have this play snowfield that is only playing one thing, we're going to make it play two things. So both of our sounds are going to be playing. I will, before I continue and I forget, select the attenuation in this section and select the snowfield attenuation. So both sounds have the attenuation. That being said, this second sound is not going to be attenuated ever, which is the dark. Actually, it will be. This first attenuation won't be attenuated from here on out. I'm also going to go ahead and select the positioning so to have the same effect later down the line. The idea here is that this sound is going to play when we are not on the snowfield, and this one will play as soon as we transition. For that, we're going to go back to our game sinks, and I'm going to go into states. I'm going to right click on the states and create a new state group. This state group is going to be called on snowfield. So basically we're checking is the character is on the snowfield or not. The state is going to change from on snowfield to off the snowfield. And for that, we're going to have two states. So we're going to say on when it is on the snowfield, and we're going to say off when it is off the snowfield. And everything is going to relate to these two states. Now, worth mentioning, as soon as we get into the engine, we are going to need to make the state clear from the very beginning. So that is going to be important. But for now, this is going to be enough. Now, next thing, as we mentioned before, we need to make it so that each sound that is going to apply or have some sort of reaction to the states changes depending on that. Therefore, we're going to go into the audio source that we're going to be playing with, which is going to be these two, and change how they react. So in the states, we're going to add the state group that we have, which is going to be the on snowfield state group. We're going to tell it how it reacts when the state is being tracked. Now, again, we're not going to touch on the none because we're going to initiate this state later down the line. But if your sound does not have any reaction to that, you could change it through here. And then when it is either off or on or something extra, it creates some sort of extra dynamics, right? So in here, in the state group, we are then going to change the voice volume for each of our sounds to adjust to our needs. So the voice volume is the thing that we're going to focus on. So this sound is going to be playing when we're off the snowfield. So when we're off the snowfield, this is the when it's off the snowfield, the volume is not going to change. When it is on the snowfield, this volume is going to go to 0. And then the opposite, the other group, we're going to do the opposite thing. When it is on the snowfield, it's not going to change. When it is off the snowfield, we're going to set that volume to 0. Perfect. So now the idea here is, of course, that it changes depending on if we're on the snowfield or not. We are going to try to track that through our snowfield event. So let's go here and let's check our transport control. In here at the bottom left, you can see that we have display states check, and we can play this, set it to off, set it to on. You can see that it transitions from one to the other when I make the selection. And actually, just for fun, let's make it so that both of them go to the negatives when there's no sound playing. So if I select none and I play the event, nothing happens. And then if I select off, on, none, off, none. It's fun. Perfect. Now, the next thing that we need to check, or the last thing that we need to check here, is how fast that transition happens. If we go into our state configuration for our on snowfield, you'll see here that we have a default transition time. So if I'm playing this sound, and I'm going from off to on, and I feel like that's going too fast, I can change this transition point, let's say from 1 to, let's say 2 seconds. It's gonna go through 2 seconds before it fully changes into the next sound. I'm also gonna lower the volume of that first sound a little bit to compensate for the volume that we changed on the other one. Go back to all. Yeah, let's go to -6 here. Let's see if they're around the same. Okay, perfect. Nice. So, yeah, the next thing will be checking how this works in Engine. So in Unreal, there are a couple of things that we need to set up. First things first, we're gonna go to our Wwise browser, and in here we can go to the states, and here we have 3 things that are not reconciled, so we need to reconcile them. Perfect. So now after we have set these up, the other thing that we need to do is we need to set the state from inside of Wwise. So in this case in particular, because this is not something that relates to anything else, I'm just going to go ahead and transform the blueprint class in the level blueprint. So I'm gonna go to the level blueprint. This is just level blueprint access. And then on begin play, I'm going to go ahead and look for set state. This is not it. This is for the animation. So that's set state, and you need to look for the autokinetic one. There we go. So in this, you can find what the state group is. In our case, is the on snowfield one, and we are going to select off. And it is not until this changes that we make a difference. So if I just play it right now, because nothing else is changing, we should be able to set that value up without making any of the other changes. So actually, before we do that, let me check that the sound is working correctly in the yeah, it is working correctly. Okay, so quickly we go to the set state, and then there we go. So I I can, actually, you know what, let's, once again, I'm going to increase the distance on the attenuation. So let's make it 2000 for each of them. Oh, well, yeah, I'm changing the attenuation, so yeah. Both of them are applying the attenuation, so both of them get the same. Save, go to soundbank, generate checked. Perfect, let's go back. That should change my sizing. It's a little big, it'll do like 1500 in a bit, but yeah. Have it there, and then in here it should still be all-encompassing. I am noticing also, sorry for that, that I need to change my configuration to make it not change positioning. Because it is making it a little bit weird on the side. So I'm gonna change both of these for that as well. In reality, it shouldn't matter. It just makes it so there is a difference from between the SARs and it doesn't sound completely. So I'm gonna turn off the specialization for that. Okay, let me go ahead more time. Soundbanks, generate checked. Perfect. And now the last thing that I'm gonna do is well, now that we know that it's playing, we need to change the configuration of the snout patch. So we have our switch controller, and in our switch controller, we have the configuration that when actor begins overlap, we are changing the switch. Because this is a tool that we have kept modular, we're going to do that configuration from our snow patch blueprint instead of changing the switch one. So for that, I'm going to add a new variable. We're going to do the same process. This is going to be the snow patch trigger. Then change this transform to trigger volume object reference. It's not a matrix and it is public. And then from this, I'm getting on actor begin overlap. We change the state. So this is going to be a set state for the autokinetic. And then the thing that is setting is to on snowfield on. And then one more time, we get on actor end overlap. We set the state to off one more time. So when we walk in, the state is set to on. When it walks out, we set it to off. Compile this. One more time that I just remembered it is that it said that I was going to change the area. So let's put this 1500, save, generate checked. Okay, let's try this out. So minimize this and without sound, and then when we walk in, it doesn't work because I haven't fed the changes into the details. So in here, I'm going to select my blueprint. And here we have a snow patch trigger. That is going to be this one. Let me lock it back again. Snow trigger is going to go here. It doesn't, because I selected the wrong type of trigger volume, right? It is not a trigger volume. It is a trigger box object reference. Save that. There we go, snow trigger. Step out, and then when we step in, we have the transition. We hear also that we have the transition from one into the other, that it takes the 2 seconds that we had added for that configuration. Perfect. So that's pretty good. Now the last thing that we're going to touch on for our configuration today is game parameters and its relationship to game sinks and also blend containers, which allowed us to change or utilize the values that we have measured or values that exist within the game to mix between 2 different objects and make them transition from one into the other, depending on certain specific values that we're going to use. This example is going to be a little bit different to the things that we have used before. And for that, I am going to go ahead and utilize a different sound than those found in the GDC pack. If you use Soundly, you can use sounds that are similar to that. But I just went to one of the pages for free sounds that are available in the BBLearn page and went ahead to look for a heartbeat sound. We're going to use a heartbeat and we're going to make it sound different compared to the speed of the character. So that if the character starts to run faster, the heartbeat also goes faster. And if the character is walking, it walks slowly. So we could put that sound on top of the player character, but we're just gonna assign it to a box so that as long as we're running around the box, we can hear it. That way it will be a little bit easier to use it as an example and not just to overcome the soundscape of the project as a whole. Okay, so let's jump right in. So there are a couple of things that we need to do in Unreal before we jump into Wwise. The first one is that, as you have probably seen, we don't necessarily have a running mechanic. For that, we are going to need to develop it. So that is going to be relatively simple. I am going to go into my input section, and in my actions, you'll see that here I have the look, the jump, the AI move, and the AI mouse look sprint. So I'm going to create a new one. This should be a new input action, and we are going to use that input. So let me look for action to create a sprint, and then to explain or to tell the game what do I want to happen when that sprint happens. So this is going to be AI sprint, not sprint, sprint. Perfect. Now, the next thing that we're going to do is we're going to open that, and we're going to change not the description itself, but the configuration for what to do with that box. So after creating our sprint dataset, I am going to go back into my control configuration. And in here, I'm going to open the default configuration and see what my actions are. You'll see here that we have the default key mappings, and in my mappings, I have established what are the movements for jump, for move, and for the look. We're just going to add a new one. This is going to be our AI sprint. And then it is in that AI sprint that I'm going to make the configuration. So let me make this bigger. This allows us to change any key that we're going to be utilizing. We can also click on this keyboard and it allows us to lock a key. In my case, that is going to be the left shift. And then we are also going to change our triggers. So in here, we're going to tell it what do we want to happen, like what has to happen to the left shift for this action to be activated. We're going to click on down. So if we press the key down, then we activate the motion. And that is it. That is all that we need to do here. So basically, this is just a thing that is saying when the shift is pressed down, we activate this ability, this action. Perfect. I'm gonna save that. We're gonna walk back, close our sprint configuration, and then the next thing that we need to do is just to go to our character controller and make use of that sprint action. So I'm gonna go back to content, first person, and then in blueprints, we have our first person character controller. Let's open that. That is not the blueprint. Open full blueprint. No, this is not the one that I have been using. It is the other one. Browser, first person character. There we go. So in here, we need to create a new event login that is going to be calling our event. So let me right click here and look for our sprint. So here we have our AI sprint. And then when this is triggered, we are just going to make the speed evolve for a period of time. So for that, we are going to just create a quick operation. We are going to get the character movement, and then we're going to change it depending on what is happening here on the sprint configuration. Let me save this. So I'm going to grab my character controller, my character movement controller from here, up here. And then the thing that I want to do is I'm going to set maximum speed, max walk, set max walk speed from the character controller, and we're going to change it from something to something. We know for the selection process, and because you can read it here, that the value right now is 600 centimeters per second. So we are going to say that when it runs, it goes to 1000, and when it is not running, it goes back to 600. Oops. Perfect. And we're also making this selection. And from here, when the character is starting to run, every time that you press or the action is triggered, we are going to set the speed to 1000. And then when it is completed, or we're no longer pressing the key, it goes back to being 600. Because we created our whole footsteps motion considering the character's speed, this should work as intended, and I should be able to just go back and then run when we press the spin key. I don't know if the character is running as we intend to, and that may be because I may be using the wrong AI sprint. That's one. Do I have another? I may have triggered the wrong one. Let me check. Yeah, there we go. Perfect. So the character is running right now. And now that we're utilizing that, we're going to create a new box, and that box we are going to utilize the audio for. Okay, so in Wwise, there are a couple of things that we need to do or make use of. The first one is going to be finding and utilizing the audio that I was talking about. In my case, I went ahead and found this audio from, again, one of the free resources in BBLearn. You can just grab the same one. It is a heartbeat. I just found it looking for heartbeat. It was free after registering, and it's a high quality WAV file that I'm going to now import into Wwise. I'm going to put it into the full work unit, click on import, place that one because I had already done this example. Let's listen to it for a moment. Double click it. So I have this, and now the intention will be for when the character starts to run, for the pitch to change and then go back. So perfect. A couple of things that I need to do for this audio in particular. First of all, let's go back to our designer layout. I'm going to select my noise, go to sound effects. I'm going to, first of all, go to the all conjunction. I am going to loop it. So let's loop it. It's an infinite loop. These are beats, so I should have no problem with a popping. Yeah, that's perfect. The next thing that we want to do is to check for, I'm going to check the volume, seems pretty good. Actually, it may be a little bit louder. Let's put 4 dB. Yeah, it's pretty good. Perfect. I'm going to save, and let's create a new folder so that I can, let's call this the RTPC box. Put this audio source inside. Cool. And now the next thing that we need is to create an event that can be used utilizing our audio. Before we do that though, I'm going to go to my game sense and we're going to create a new game parameter. Now, game parameters are based on a range. So let me create a new one and we're gonna do that from there. Game parameter is gonna be called speed, but actually correctly written. Speed is going to be a value between a range of one thing and another. That actual range is not going to be as relevant as the actual number that we're going to use in the game. The important here is that whatever distance you have is going to be the reference inside of Wwise for what that number is going to be, and then that can be or will be transposed to the number that you're going to use inside of the game. So in my case, I'm going to leave it at 0 to 100, and the additions that I'm making in Wwise will be measured on that value from 0 to 100, and we can check what the equivalences are. And then we are just going to superpose that with the configuration in Unreal. So for that, I am going to go ahead and go back to my audio. Here in our audio list, we have the RTPC. I'm going to select the new thing, and I can select what do I want the RTPC to edit. In my case, that is going to be voice pitch. For what it is, I'm going to select the speed. And here I can select how I want the value to change in that range from 0 to 100 in our configuration. So in this moment, it is just to 0. But if I put this value here, you'll see that the closer that I get to 100, the closer that those values are. I'm going to leave it at like 1500. Let's put it like here as our maximum. And then 0 is 0. That's the pitch that we have been using. So as the speed changes from 0 to 100, so 0 being the base, in our case, the speed that the character controller has, and from 100, that's what we're going to have. Perfect. All right. Now, the next thing that we need to do, so the last thing that we're going to do is just check how this works in our transport control, just to make sure that everything is in order. I could select it here, and then in here I should be able to change our speed selection the same way that we have been doing it over there. It's working correctly. So finally, let's just make a new play event. So this play event is going to be called play heartbeat. And our play heartbeat will contain our heartbeat sound. So let's create a virtual folder, and here let's just say RTPC, and let's put play heartbeat into our folder. Perfect. All right. So I think that that's the last thing that we need to do in our in Wwise for now. So let's go to the engine. So in Unreal, there are a couple of things that we're going to be doing. The first is let's set up our cube. So we have covered a lot of distance. Let me grab this, put it back in 0. Oops, nope, that's not it. Okay. Forgot that I had this locked. There we go. So select this back. 0. Now. There. Okay. Let me create a new place actors. I'm going to look for let's go to sphere. Let's get crazy. So here we have my sphere, and this sphere is going to contain our heartbeat. For that, well, we already have the event, so that is going to be really simple. I just need to go to my content drawer and find my audio player. So I'm going to add the audio player here. I'm going to select the things. So what is the actor? Oh my God. The actor is going to be the sphere, and then the footsteps that I'm, the audio that I'm going to play is not here. It is, of course, part of our RTPC examples that are not here because I didn't generate my sandbanks correctly. Oh no, it's not because of that, it's because I didn't add them. There we go. I checked. Perfect. And then in here, let me reconcile. Excellent. So, selecting our sphere, I'm going to go ahead and change our audio player event. And the event is going to be, of course, the play heartbeat. Excellent. Let me move this sphere into our folder. Let's add it to world tutorial objects, and then here, let's call it RTPC. And then here is our sphere. Perfect. So, the sphere doesn't count attenuation right now. I'm going to configure that in a bit, but we can hear the heartbeat sound. Great. So a couple of things that I need to do. First of all, I'm going to use the same attenuation as the boxes to change my configuration for set attenuation, default work unit, for I use the box attenuation for our sphere. Let me go to layout, sandbanks, generate sandbanks, save. Now we shouldn't hear it. Perfect. Okay, that gives us an area so that we are not always listening to the heartbeat, but with a heartbeat you probably would be listening to it far away. This is just a good example of heartbeat. So now the next thing that we need to do is to set up a change in the RTPC values, measuring our speed measurements. So for that, we're going to go back into my first-person character controller, blueprint, and the first-person character, and we're actually going to make the change here in the move section. Same as we were doing with the sprint. If you click down here, you'll see that we have most of the motion that we're doing whenever the character moves. So whenever the character moves, we want to be able to set that RTPC value to something, and then when it stops moving, we want that RTPC value to be something different. So with that in mind, the thing that we're going to do is we're going to go ahead and set an RTPC value. So we're going to use the set RTPC real-time character control value. Click it as a game object, and then we're going to break this link and trigger the area so that whenever we move, we change that character control to something. Now, it is important for us to measure that the RTPC value that we're measuring is going to be looking for a value between 0 and 100. And the RTPC values here then we know that our measurement of speed are measuring like up to 600 or 1000, depending if the character is moving or not. So to be able to get that speed, I am going to use the speed value in on itself, and then we're going to divide it by 10 so that the speed is correctly addressed. Also, I'm realizing right now that the RTPC value is not synchronized, so let me go into my game settings and synchronize it, reconcile it. Perfect. So we go back here, select our RTPC value is going to be speed, and then we're going to get that character controller, which I had already gotten before, but it's fine. And from this, we're going to get the max speed that the character is going to have. So this is going to be the maximum value that the character has, and we know that we're changing this value every time that we're sprinting. So this is going to be really useful. I'm going to return this, and that value is eventually going to go here. But first, I need to divide it so that it goes to, it divides by 10, so that we have a value of like 60 to 100 if I'm at 1000. Perfect. And now the last thing that I need to remember to do is to reset the value. If I reset RTPC, it will just go back to 0. So let's say space, and this will happen whenever the character stops moving. So this is going to select uncontroller. I'm also realizing that I don't have a target immediately for it, which means that I am using the wrong RTPC configuration. So it should be this set RTPC instead of this one. Now, you'll see what the changes is. This is really similar to the difference that we had for the post event and post associated event. Set RTPC value is just loading a global variable. So whatever is being added or changed by this RTPC value is being affected. This one would only affect the AKM object associated with a specific target. Therefore, because we're just utilizing global variable, we're going to use this one on top instead of the one at the bottom. Let me erase that, put it a little bit lower, and connect that value there. So let's compile this. Look that we are doing the correct thing. And so far, that should be enough, and we should be able to make it work from there. Let's see if it works. Fingers crossed. So I should be able to work here. We have the heartbeat when we're standing. Gets faster when we're walking. Gets even faster when we are running. Perfect. So that way we have like 3 stages. Completely not moving, it's at 0. Then more or less at 60% when we are walking, and then at 100% when we're running. That gives us a vibe for the type of changes that you would use RTPC values for. This could also, instead of reference speed, could be referencing something like health, and that would also make a lot of sense. So yeah, that's how you apply them in Unreal. So the last thing that we're going to check in Wwise for this week is going to be the utilization of a blend container. A blend container is really good to try to mix between multiple subsections of sounds to play one after the other according to either one of the parameters that you have or that you are controlling in your game, but also just if you have like a continuation of sound that you don't want to play like either one or the other, but you want to create like a nice transition that goes back and forth in between, you can do that. And you can utilize it utilizing the same, you can do that utilizing the same RTPC controls like the one that we were utilizing just in a little bit, but also you can use other type of values for that to happen. So for that configuration in Wwise, the first thing that we're going to do is we're going to change our RTPC box, and we're going to add a new sound to that. In this case, I went ahead to our GDC folder, and I looked for horror to find this sound, which is the digital horror whoosh. I'm going to add this here, import it into my RTPC box, and then actually I made a mistake. That's not the one. It is the rice. Listen to that. Yeah, I picked that one because it feels appropriate for the end, because we're going to attach this to the object in which we're playing the heartbeat. So the idea is that it's going to go into the heartbeat and then change into something else. Now for that, I will need to change what these files are being contained on. So instead of being just a regular folder, they are going to become a blend container. So I'm going to create a blend container. I put it inside of the RTPC box, and this is going to be called, let's say, RTPC blend. And I'm going to add both of the sounds to it. I don't need this extra folder, so I'm just going to add both of these into the box folder, and I'm going to delete the RTPC box folder that I'm not using anymore. So I now have the heartbeat and the extra sound present, and we are going to change this configuration in the designer layout so that we can play the sound. So first of all, when you get the blend container, there is the configuration here that appears. We can change or select what the what the configuration of the blend container is going to be. For that, we're going to add a new blend track, and in this blend track, we need to add the 2 sounds that are going to be changing. In our case, we're going to add both of the sounds that we have present here to the blend track. And then we're going to select what is the change that we're going to have. In our case, that is going to be the voice volume. And for that, we are going to use the same speed measurement. So basically, when speed changes, that is going to happen. Oh, okay, no, I made a mistake. So if we select in crossfade and we select the crossfade, sorry, and we select speed, here we're going to see the track gene utilizing both of our sounds. There we go. So now we see, as we make the transition, how it goes from one thing into the other. Because our sounds are these, and of course the horror sound, we need to adjust the values a little bit. For that, I am going to utilize the knowledge that I have of the values themselves. So like that the walking speed is like around 50, around 60 or so, that 100 is like the maximum speed that we're going to utilize. We're going to make it so that when the character is standing still, you can only hear the heartbeat. The closer that you get to that walking speed, you can hear like the edge of the speed, but the faster heartbeat. And then when you're at 100, you just get to. Now, this transition would be a lot nicer if we had the possibility of doing like a transition of speed, like the speed went from like 0 to like 20 to 40 to 60. But in our case right now, we just have these values. We're gonna make use of them. So the last thing that I need to do is, of course, add attenuations. We were using the box attenuation for the other object, so we're going to use that same one. And that's it. After configuring the audio, we're perfect. So let's create a new event here. It's going to be a play event. And after deleting the other one, this is going to be our new play heartbeat. We're going to add it to the RTPC folder and then add it into our soundbank layout. So we have our event, play heartbeat, add it into main, generate checked, and then we just check how this looks on engine. So in Unreal, the only thing that we need to do is, of course, reconcile our heartbeat asset to make sure that it is working correctly. And then when we are in the game, we should be able to hear the heartbeat sound when we're walking, the heartbeat getting faster and the edge of the other one. And when we run, we have this sound, the horror sound on top. It's not a great example of the use of this because the heartbeat and the other one don't mesh perfectly between one another, but you can see how it reacts directly to the information that I'm giving the object. Okay. Now, with that, we're gonna leave our work in Wwise there for this week. As I was mentioning in class before, these are all parallel processes that we're going to be utilizing as we continue to implement audio into our engine works. The idea here is, once again, for these to be tools in your toolbox, things that you can use depending on how you want your sound to react as you continue to create things in your games. It is also very important for you to like know when to use something like a blend track or when to change the space of states. But it is also important for you to familiarize yourself with these processes so that you know how to access them when you need to. But that's gonna be it for me. Once again, if you have any questions or any issues, please make sure to send me an email and schedule office hours. And that's it. So thank you so much, and I'll see you in class.